So hi everyone, my name is Trevor Menagh. I'm here to introduce the speaker today. Oh, that's me. I'm also part of the Philly ETE committee that helps organize this event. I'm a big fan. I've been going for about 3 years now. A little bit about myself. I'm a guy who wants you to test your code, really test your code. I started programming about 10 years ago. And I did C, like everyone did C back then, right? Actually, God, it's more than 10 years. But yeah, no one did testing. And that was during the dot-com boom. I then lost my job and went off to Japan and did not programming for a long time. And I came back and started getting into programming again. And a friend of mine got me into Ruby. And everyone in Ruby is really into testing and really into code quality. And that got me excited about testing and code quality. So later on, I transitioned and I started doing more and more JavaScript. And I brought these ideas from Ruby, this idea of like code quality and testing your work in JavaScript. And at the time, I was like, all right, let's do some unit testing. And it was nothing. I felt like I was back in the 90s when I was working with JavaScript and unit testing. So that's where this passion comes from. I'm going to show you some tools about how I personally do it here at Comcast, which is the company I work for. And hopefully we can learn a little something. Just a show of hands, how many people here are JavaScripters, like write JavaScript? Oh, good. How many people here like you don't just do JavaScript, or your company doesn't just do JavaScript. How many of you guys are in the JVM somehow? Okay, good, perfect. So I write JavaScript. I'm on the JVM, and the things I'm going to be talking about are about that group. That doesn't mean you can't apply these things to Ruby, or if you have the ability to go to Node. There's lots of really great tools out there in Node that are solving a lot of these problems. But this is about the enterprise, and I use enterprisey tools. So we're going to talk more about that. All right, that's me. So to start out, there's this thing called SICK. I don't know why it's called SICK. It's a pretty sick acronym. They talk about software quality, and there's all this stuff, reliability, blah, 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 right? So some academic thought they'd create a paper about this. But I don't care about that, really. Really, you're an engineer. You're an engineer. Like I want to say everyone in this room is. And what the difference between an engineer and a programmer, or an engineer or a coder or a tester, is that an engineer does quality work, right? So what that means is that you care about your work. So what's quality work? Quality work is that something you really you care about. That when you produce stuff, you're not just producing it, throwing it away. It's not just your day job. It's something that really matters to you. Something that you're proud to show off. When you're done, you're like, hey, I did this. And you could be proud of the website you're working on, or proud of a function that you figured out how to do, something that you really care about. And something that you're not afraid to change. So this is an important piece of it. Oftentimes, when I'm really proud of something, I don't want anyone to touch it. And I'm afraid of people looking at it and saying, that's wrong, you're an idiot. So part of me wants to give that up and say, I want to be able to not be afraid to have my code changed. And the only way I can feel confident and not be afraid for my code to be changed is to test that code. It's really important in a dynamic language like JavaScript. With static typing, there's a lot of types of tests you don't have to worry about anymore because the compiler catches it for you. But with JavaScript and Ruby and Python and other dynamic languages, there's things that you have to test. Because if you don't test it, you're kind of up a creek. So you write JavaScript, I write JavaScript, we're JavaScripters sometimes. And writing quality JavaScript is hard. Now, it's hard because it's dynamic, and you have to think of a lot of edge cases You have to think of things that you don't necessarily have to think of in a statically typed language. And as if you guys were at Doug Crockford's first talk, he pointed out a lot of the bad things about JavaScript. There are lots of pitfalls in the language, and you can write bad code really, really fast. Everyone, if you wanted his talk, really use JSLint. JSLint's how I learned JavaScript. I would write some JavaScript, cut and paste it into jslint.com, and run it, and see what an idiot I was, and kept on doing that until it was ingrained in me. So you have to know what to do. You have to know what to do when you're writing JavaScript. So you have to namespace your functions. So everyone names, for God's sakes, namespace your functions. Oh my God, right? But you know how to do that, right? You're good. You're a rock star. You should declare your variables up top. Doug Crockford talked about this. But you already know that because, again, you're a rock star JavaScript coder. You know this, duh. Hoisted. I didn't know they were hoisted until yesterday. You encapsulate your code in ifs. The cuss is an iffy, right? That's what the brackets are right there. So you encapsulate your code in these immediately invoked function expressions. That's really hard to say. That's why we call them ifs. And that makes sure that you're not polluting the global namespace, which is a good thing. So the global namespace is everything outside that iffy, and you don't want to be doing stupid stuff out there because that's bad news bears. And you know what not to do. You are a smart guy or girl or woman or dog, I don't know. And you know not to use with, right? Again, Doug Crockford covered a lot of this stuff, and he's a smarter guy than I am. So you don't use with because it's ambiguous. And you always remember to use var because, see this I right here? This actually happened to me the other day. I was debugging code. This sucks. Like, you're writing code here, and you're like, da, 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 and all of a sudden something doesn't work. You don't know why. You're like, for, I's declared right there. It's no problem. That I's global in JavaScript. That sucks. You don't have a var right there, or you don't have a var at the top of derp, then that I is global for everything, and the next time you use I, you're going to screw something up. So you remember that, because you're smart. And you don't abuse eval. So eval, I think every language in the universe has eval, but eval's kind of, some people call it evil. I don't necessarily think it's evil, but it is slow and hard to optimize for your compilers. Like once you're in this eval world, you don't know what's going on over there, or your compiler certainly doesn't. But almost everything you can do with eval, you can do without eval. There are edge cases, and I'm sure there's a couple of people eager to tell me, actually, there are some things you need it for. But fine, very few things do. So stop that. But like I said, you know all that. Because you're a rock star. You're awesome. Way to go. Yeah. No, you're not. Right. So, God damn it. So you're not a rock star. I'm not a rock. Nobody's a rock star. Maybe Doug Crockford's a rock star. I'm not sure. I don't work with him every day. But no, I mean, we have this attitude, and I've seen this everywhere, where I'm confident that what I do is good, and well, I don't need to really test my work because everyone knows that this will work. There's this concept called the false consensus effect that says, well, I'm not so smart, and I figured this thing out, so anyone else that looks at this code will obviously figure it out because everyone's at least as smart as I am because I'm not that bright. So, okay, I'll just assume that you know this, and it's okay. Well, unfortunately, a lot of the code that we write is stuff that even future me looks back and says, why do you do this? Future me often hates me from right now. And me from right now, I guarantee you, dislikes me from the past, because that guy's a jerk. And I think a lot of us feel that way when we look at code that's even 6 months old. So that in and of itself is a good reason to test your code, no matter where you are. We all write bad code every single day. I bet you there's a guy in the back of the room right now writing bad code. And future that guy will be like, why did I write this code at a conference? You know? But you know, that's okay. It happens to all of us. So we especially write bad JavaScript. JavaScript's really easy to do poorly, unfortunately. Really great language. I love it. I think it's fantastic. It has a lot of the cool features of functional languages that I love. I love that functions are first-class objects and you can pass them around. I love callbacks until you get to callback hell. That sucks. But you know, JavaScript's cool, but it's easy to do it wrong. Really easy, you know? So we write tests. This is why we write tests, because programming sometimes is hard, and you from the future is going to regret that you didn't write tests right now, okay? So you write tests, and you write tests in JavaScript, because you know, you could, I've talked to people that have written tests in other languages, and that's cool. Like you have RSpec set up, and you're like, I'm just going to run RSpec tests, or I'm going to run integration tests. Now, what I'm going to be talking about, what I am talking about right now specifically, is unit tests. So there's unit tests, and there's integration tests, and then there's 1,000 other types of tests, like functional tests and smoke tests. But really, the main difference between functional, integration, smoke tests, whatever, and unit tests are that integration tests test the entire system. They test that if everything is hooked up correctly, that my system works. Very useful type of test for testing your entire system, and you want those. But what I really care about right now, and what I want to try to convince you of, is that that unit tests are very important. That testing one function, that if you put something into the function, you're going to get something out of it, or if you put something into that function, and you're going to get some sane side effects, that's important. And the reason that's important, the reason testing one little piece of code is important, is because later on, you or one of your much smarter coworkers will realize that you implemented that function poorly. So they can go in with much confidence, change how it's implemented to be faster or better or stronger or more invincible, I don't know. And they'll have confidence that it still works because you wrote a test for it. You know, that's what testing is all about, being confident with your code. And this is something that I first learned about years ago and started to embrace. But the secret about testing is that it's really hard and time consuming, and I don't want to do it, oh God. You know, a lot of people say that. I felt that way too. It's hard and it takes more time, and then you have to increase your estimates, and bleh, you know, it sucks. But, you know, it's so worth it. The cool thing about doing unit tests is that if you do it right, you can run them on your CI server. So one of the CI continuous integration server, like Jenkins or Anthill Pro, there are a couple enterprisey solutions out there. We use Anthill Pro at work. We just transitioned off of Jenkins because we like to pay money for things at Comcast. I have no idea. I'm hopefully going to show you how to do it in Jenkins, which is free, which is nice if you work in a smaller, medium-sized company. One of the things that when I started writing tests in JavaScript, and I chose something called Jasmine. There are lots of JavaScript unit test frameworks. If you're a Java guy and you're very comfortable with JUnit, there's a fantastic one out there called QUnit. QUnit is what jQuery uses to test all their stuff. It's awesome. Like you'll work with it right away. I picked Jasmine because I came from Ruby and I got totally obsessed with RSpec. That's how I actually figured out how to do testing. And Jasmine looks a lot like RSpec, right? So one of the problems was that none of these things worked well on the command line. So being from Ruby, I liked having to run RSpec, and it spit out some nice stuff on the command line. That was awesome, right? And the advantage of having something that runs on the command line is that you can run in a CI server just fine. I can put this in Maven, in my Maven workflow, and have it run and spit out useful information. Nothing like that existed when I started. Everything was browser-based, which is really, really cool if you and your team don't have this stuff running on a server. You know, if you have it where it loads a web page and your test load on a web page and you have the green and red things, it's really neat, but not very useful to automate, right? So we created a system where you can automate it. And once you put it in the CI server, your front-end engineers can break the build. Breaking the build's awesome. So before, what I mean by break the build, when we started this grand endeavor of continuous integration, the entire point of it is that you write tests, and if you wrote some stupid code that breaks someone else's test, it blows up and emails everybody, and your manager comes in and says, "You're an idiot." And so that was great, and the Java guys have been doing this for years, and so they know they're idiots. But we JavaScripters had no idea how stupid we were, right? So my goal in life is to teach JavaScripters how dumb they are, and like myself, you know. And I do this with tests. I think that's a wonderful thing. Being able to know that I wrote a piece of JavaScript that is going to break something down the line right now is so useful, you know. And that's what breaking the build is really about. We hear about it, and you know, there's that gut reaction like, "Oh no, I broke the build. That's a bad thing," and it is. But the entire concept that you can break the build instead of shipping that piece of software that will break the entire server, bring down your system for an hour, and cost $10,000 to the company, that sucks. I'd much rather get an email sent to my manager and have it taken care of way before. So it's good, even though it feels bad, right? So like I said, I'd use this with Jasmine, UQUnit, Maven, which is if you don't know Maven, Maven's a build system that runs, you get this big ugly XML file and you turn it into something that builds, like builds your stuff in Java. Ant, another one, Rake, you guys probably already know this stuff. And then Jenkins or Anthill Pro, like I said, for the continuous integration servers. So that's enough of me talking. Now I'm going to foolishly do some live coding. And this is like a bucket full of regret. Most of me doesn't want to do this, but I'm going to give it a shot anyway. I'm going to, using Jasmine. So first of all, how many of you are familiar with Jasmine? Written Jasmine code? How about how many of you guys are familiar with RSpec? Sweet. OK, good. I'm going to try to do some test-driven development on three simple examples. One is just a hello world. Another one is using callback, and another one is using Ajax. Now, callbacks and Ajax are some of the things I hear most commonly when people say, "Hey, Trevor, I can't test my code. This code is untestable." And a couple guys I work with know that that's a very annoying term to say that your code's untestable. And I have one coworker in particular that has proven that wrong time and time again. Someone will walk up and say, "This JavaScript's untestable," and I'll say, "Oh yeah," and then make it testable. It's definitely possible, and hopefully some of the things I go through will make you feel good that you can test your code. And I'll take questions afterwards, and you can try to get me, and that'd be great. So let's give this a shot. Is that big enough? Yeah, it's big enough. OK, great. So let's go into everyone's favorite thing here. So this is Vim. And so this is, if you're familiar with Maven web projects, this might look a bit familiar. I have a test JavaScript, and this is where I have EnvJasmine. So EnvJasmine is a tool that we wrote that takes Jasmine and makes it so you can spit it out in Maven. I'll have links that you can look at later if you want to do this on the JVM. So I go in here, and I'm going to let's create a spec. So we'll add a spec, and we'll call it, I don't know, demo.spec.js. OK, great. So first of all, we have to do EnvJasmine.load. So we have to load the file that we want to test. I haven't written the file we want to test yet, but let's assume that I will. I'm going to use my cheat sheet because I don't remember what I called that. Hey guys. Oh, Trevor, you've written all the code. Yes, that's right. So, all right, there we go. Boom. EnvJasmine.load. demo.jsdir. So one of the things you do when in this tool is you set up a directory where all your JavaScript's going to be, and then you go here demo.js. All right, so that's great. I have the thing now. I'm going to describe. If I'm doing something wrong, someone call me out. All right. Describe it greets, or let's say greeter, namespace.greeter. So we'll try to create something that greets you. All right. It greets Trevor. Function. So this is the format of Jasmine. It looks like RSpec with a bit more cruft, I think. So I want to expect this thing that I haven't created yet, ns.greeter. If I pass in Trevor, to equal hi, Trevor. So really straightforward, right? It's kind of a no-brainer. So let's try to run that guy. So I'm going to run my tests. So all this is doing is it's going to load up Rhino, which loads a bunch of stuff, and it'll tell me, hey, you don't have a demo.js, dumbass. So now I have to go create this source main web app JS demo.js. Okay, no problem. All right, let's do that. So I'll go here and create demo.js, right? Boom, boom. Save it. And run this guy again. Not that guy. Not that guy. All right, here we go. And hopefully, yeah, perfect. So red's bad. Let's fix it. NS is not defined. Okay, so now I have to define my namespace. So let's make it easy. Let's keep it simple. That's equals. Okay, so now I have a namespace, and I know for brevity's sake, let's create a greeter. So let's do ns.greeter. Now the reason I create a namespace again is because I don't want to pollute the global namespace. I don't want to have function greeter just in this area here, because if it's not within that namespace, then greeter is available everywhere to every JavaScript file that is here. And if someone else stupidly decided to create another function called greeter, there'd be a conflict there. That's why you namespace, right? So this is going to equal a function that's going to take a name and semicolon. And then you're just going to return hello plus name plus. This is the easy example, right? So hopefully that works. And one says hello, another says hi. That sounds like a crappy program. All right, so hi, oh hi. Obviously you can see that this is going to do the trick here. So that's pretty simple, really trivial example. You're thinking, yeah, that's brain dead, I could have learned that really fast. Okay, great. So the reason I wanted to live code this stuff is because I wanted to show you that it's not that much more effort to actually test stuff. Let's create a callback test. All right, so I'm going to create my spec first. Let's call it callback demo.spec.js. So this is where things are going to get a little bit more interesting, hopefully. So here we go. EnvJasmine. Oh, you son of a gun. EnvJasmine dot load, and we'll just go to our JS directory again. Jasmine.jsdir plus callback. So callbacks are really useful. We all use them everywhere. But they tend to be kind of harder to test because if you have a function that gets a callback, then you're like, how do I do that? And what you need to do in Jasmine, and it's the same in almost any other language, is you need to create either a mock or a spy. So before I do this, let me explain mocks and spies. So, hey, how many people know what a mock or a spy is? All right, most of you. That's awesome, right? It took me a really long time to figure out what a mock or a spy was. I'm going, since not every hand raised up, I'm going to explain this a tiny bit. So when you're doing unit testing, remember I said unit testing tests one function. That means that if this function calls other functions or invokes other functions, I don't want to test those functions. I want those functions to be fake functions. I only want to test the logic of my function, okay? When you test the logic of one function, you don't care about any of the other stuff. That's if you depend on data from outside sources, so if I have a function that calls two other functions and I depend on data for those when I'm running my test, that's not a good unit test. I want to return fake, reliable data so I can run that test offline. That shouldn't matter. The data that comes back shouldn't matter. And the same is true with callbacks, right? All I care about is that if I have a function that has a callback, that callback is called when something happens. Okay, so let's do this. Let's create a test to test this, right? So describe dot run if Signy. Signy is my wife. Function. So it is going to run a call back if I am Signy. So you can already imagine what this function is going to kind of look like. Right? It's going to be something like I'll call it like ns dot run if Signy, and I'll send in a string. Okay, Signy is a string, and then some callback. So usually I'd send in a function here, so some function that does something, right? And this function is going to take a name, which is I'm going to pass in, and that name is going to be something. Well, so at this point, I'm starting to implement it, which is kind of dangerous when you do this stuff. So let's do this. Let's actually implement it first, and then we'll go back and do the test. I know that's anathema. That's horrible. So like one of the things that they talk about doing is test-driven development. I like test-driven development, but it's really hard sometimes. That's okay. As long as you test your code, that's the first baby step, right? So let's go and write a function first, okay? So if I have a callback.js, I want to do something like this. Var ns equals this, and ns dot callback equals a function that takes a name and a callback, right? And we'll just say if name equals Signy, then callback name, right? Else return, right? So that's pretty simple. So how I test this without actually writing a callback to return. And the key is spies. So let's write a spy here. So I want to create a spy that's going to be a fake callback, right? And we'll do Jasmine.create spy. So what this is doing is just creating a dummy function that I'm going to be able to do some interesting stuff with in a minute, right? And now all I'm going to do is I'm going to call that function. I'm going to do ns.callback and pass in signy. And this is going to touch the if part of it, right? And pass in my fake callback. So then it's called. Now I want to be able to check if fake callback has been called. So I want to expect fake callback to have been called with signy, right? So one of the advantages is hopefully it's relatively more straightforward to read than not. Let's see if I did this right without any syntax errors. Probably not. Oh, what? Unbelievable. It's amazing. All right. Oh, live coding. So horrible. All right, so that tests the first part. But one of the things when you're testing is that you want to test both the if and the else. This is like brain dead stuff. And I know that you're like, oh, it's so boring. But I think it's a little important to cover this stuff because you have to think about it. And when you're actually doing testing, you're like, oh, I have to do tests for this stuff. But I want to show you how not so hard it is, and it's kind of worth it. All right. So one more on this, and we will move on to Ajax, which is a little interesting there. So it returns not signy, if not signy, right? And we want to make sure that the callback isn't called. So that's another interesting thing. So if I do a function, so I want to make sure that, that I'm going to create a fake function again. So var fake callback equals a Jasmine.create spy. So I'm going to call this ns callback again with my fake callback and something that's not signy. So we'll do ns.callback Trevor, that's me, and pass my fake callback. So we want to check two things here. We want to check that not signy is returned. So we'll do that in here. So expect this and its callback, right, to equal not signy. Another thing we want to make sure is that stupid callback isn't called, right? So I want to expect fake callback not to have been called, right? So those are two things I want to expect here. Perfect, right? So that's how you test callbacks. Not that hard. So there's no excuse for you not to test callbacks now. Great. So now you don't have any excuse to test regular functions, and you don't have any excuse not to test things with callbacks, right? But now you're thinking, oh, how about Ajax? Ajax is so hard. I can't test Ajax. Give up, right? But no, actually, you can test Ajax, jerk. It's possible. Don't give up. Don't say it's not possible to test things. Right, so, so I'm going to show you another boring demo of me testing Ajax, right? I'm this close to not doing it because, like the dead time of me typing, oof, that's killing me. But I'll do it because someone said I should. That guy. All right, so fine. You can blame him out. His name's John. He really wanted to see me type in front of everybody. So, so here we go. Let's create an Ajax spec. So, modify Ajax.spec.js, right? Again, these are tools that you don't have to use EnvJasmine. It's just what I use. One of the things that I liked doing with this, one of the reasons we created this is because there really wasn't that much tooling out here to do this when I started. There's a lot of tooling out there right now, especially if you can do Node. If you can do Node, PhantomJS is pretty awesome. Does a lot of this stuff on the Node stack. Mine does it on the Java stack. Regardless, the tests are basically the same. So let's include the file that we're going to create. Load EnvJasmine.jster plus Ajax.js. All right, so easy. One of the things I'm doing is I'm including jQuery in here. So a lot of people use jQuery. If you don't use jQuery, you can use some other thing. This is going to be specifically testing jQuery's Ajax calls. Okay. So I want to describe Ajax-y stuff, right? Oh, I spelled that wrong. Doesn't matter. So if I did this, I wanted to say it calls a success function when Ajax is successful. Right? Great. So that's something that you probably want to do. The thing with this stuff is a lot of times we write Ajax with a success function and an error function or a fail function, depending on what version of jQuery you're using, as anonymous functions inside there. One of the complaints I often get about testing is that I can't really test inside that function. One of the solutions to that is to pull that function out as a separate function, so you can test that separately. And one of the things I like to do is do that to get around this. What I'm going to show you right now is that I can test that a success function was actually called if it's an anonymous function there, right? So, oh, thanks, man. I appreciate that. So, it's good, thank goodness. That's what you need when you're doing stupid things like live coding. It's such a dumb idea. Seriously. So again, let me go back and actually write the code first. So let's write some code. Now that we have this. So all right. So I'll create Ajax.js. And so we'll do this. We'll do var ns equals ns dot, let's say Ajax equals a function that will do a couple things here. Let's say I'm going to return the result of Ajax. I'm going to get this totally wrong. You guys are going to correct me along the way, hopefully. So that takes a type, which is get, right? And it takes a URL, right? Which is users. All right. Doesn't matter for the sake of this, right? Because we're just testing stuff. Success takes a function with data, and then there's error, which again takes a function and some stuff. It takes stuff in there too. So I could go through this, but I kind of want to just show you the code because I think it's more interesting. So let me jump to that because I'm tired of typing. So I showed you this, which is pretty straightforward and says I just expect that greeter to work. I showed you this that says the callbacks work. And since this is a lot more code to type and I'm lazy, I'm going to walk you through what's going on here. So basically I'm saying that here's your Ajax call. If you're familiar with jQuery, you know this. You're like, oh yeah, that's great. And so in the success, I'm calling NSGreeter. In my describe block, I'm calling ns.greetUser and then making a spy. I'm spying on NSGreeter, right? So what I'm doing here is I know that this anonymous function is going to do something, right? I know this anonymous function is going to call NSGreeter. So I want to create a spy that spies on NSGreeter, and then later on I'm going to check to see if NSGreeter is successfully called at some later date. And the way I do that is by using this most recent Ajax request. So what I'm doing is I have something in there that's catching all the Ajax requests that JavaScript gets and stopping them right where they are, creating a mock, and saying, all right, I'm going to do something with this later. So I'm injecting a response. I say, OK, I'm going to inject the 200, and the response text is going to be this JSON string where name equals Trevor. And so you see here I have data.name equals this. And then later on, I'll expect my greeter to have been called with my name, right? So this works because of those spies. Spies and mocks are like one of the hardest things that I had to understand when I was doing testing. And once I understood them, it made unit testing much, much easier. That's the crux of what I have to say about it. I mean, with these three things, with the concept of being able to test a callback, with the concept of being able to test Ajax, and with the simple expect, really most of my unit tests are confined to this stuff because most of the JavaScript I write isn't terribly complicated. I'm not implementing Bloom filters in JavaScript. I mean, I created a web page, for God's sake. It's not that hard. Yeah?
How would you test like DOM manipulation?
That's a good question. So how would you test DOM manipulation? There's a couple ways you could do it. Again, DOM manipulation, like with jQuery, for example, is just calling functions. So again, if you spy on the function that you're calling, you don't want to actually call it to the DOM. I trust that jQuery is tested well because it is, right? So I don't actually want to go out to a real DOM for these unit tests. I want to stop right there. So I spy on this and say, oh, was this function called correctly with the parameters I want? And then I can spit back something. So if I wanted to test that I had a function that called to the DOM and returned some DOM object, what I could do is instead capture that in a spy and then return some fake data. So one of the things on that spy on is you can chain and return or and call fake and call fake something and pass in a function. And when you do that, you can get into the you can actually go and test DOM manipulation. Not real DOM manipulation, but the things that do DOM manipulation, which is really what you want with unit testing. Yeah.
So for general asynchronicity, I imagine you could say spy on set timeout.
Yeah, definitely. So that's interesting. Set timeout is an interesting beast. When you do set timeouts there, they tend to be harder to test, but you're correct. Like if you had a set timeout in your function, you spy on that, and since set timeout, like again, takes a callback, right? You just do the same thing like we talked about with the callbacks there.
Real quick, I'm sorry. The syntax in that last function, the most recent Ajax request, is that something that Jasmine provides? It's just there, or is that a function before?
So that's a good question. That's actually part of Jasmine Ajax, which is an add-on to Jasmine that Pivotal Labs wrote. Actually, there are a lot of really cool Jasmine plugins. There's actually a jQuery Jasmine plugin that hooks in and does a lot of that mocking I was talking about for you, and also gives you fixtures. So sometimes you want to do something a bit more than a pure unit test. And when you want to do that, you can have a fixture that has actually fake data and pass that in. Jasmine jQuery allows for these cool fixtures. I actually think straight up Jasmine will give you cool fixtures like that.
If you call greet user before you call spy on, what kind of cause it to be called, like your callback there, you get called twice?
So let's think about that. So I call greet user. What greet user is going to do is it's executing this Ajax call, which doesn't do anything yet because it hasn't returned, right? So that gets caught, and the success never gets called until most recent Ajax request is kicked off.
It kind of puts it on pause.
That's exactly right, yeah. And actually, to be more specific, it never actually makes that call out, right? But it just puts it on a stack. And this most recent Ajax request is the thing that lets you add responses.
So, dumb question. Jasmine Ajax, it appears that that's actually wrapping the XML HTTP request on there.
You're absolutely correct. That's what it's doing. Yeah, so Brian, right? Yeah. So what Brian said is, he said that it looks like Jasmine Ajax is wrapping XXR requests, and that's exactly what it's doing. It's stopping the XHRs from actually going out. One of the reasons I get this for free with EnvJasmine, which is what I'm using here, is that I just sneakily added those things into my Jasmine runner. So I have Jasmine, jQuery, Ajax. And again, there's a robust community around Jasmine itself. The same is true with QUnit. Those two seem to really be the most well-developed test frameworks for JavaScript right now. Are there any other questions? I'd be happy to take some, yeah.
Do you have a favorite, or are there any like either factories or things like VCR if you like do a lot of stubbing of responses to you guys?
That's a good question. So I'm a big fan of VCR. For those of the question was, are there any frameworks out there that I'm a big fan of that do sort of like capturing of API data in the form of fixtures? And he mentioned VCR. VCR is a Ruby framework or Ruby test add-on that allows you to run your test once for real, and it's like you're putting a VCR tape in, and it records the HTTP transaction, and then spits out this big YAML file that you can use in future times. So I don't know of any that do that right off the top of my head.
Like a factory that you build a response.
Like Factory Girl or something. Not that I know of, but I would not be surprised if there weren't any out there. I mean, it's conceptually pretty straightforward to build that. You just have to capture the Ajax request the very first time. But I don't know of any libraries that are doing that right now for JavaScript, unless anyone else does. You know.
Is there something like a watcher for these tests that can just run them and they get saved, and can they be written in CoffeeScript?
That's a good question. Both of those are good questions. There is a Jasmine CoffeeScript project that lets you run all your Jasmine tests in CoffeeScript. As far as Watcher, I've used Guard to do this, which is a Ruby application or Ruby gem to do watching. There isn't anything built in to this tool in particular, but you know, that stuff is definitely out there. You know.
So Guard works with these two, that's fine.
Oh yeah, sure. So Guard, for you guys that don't know, Guard is a Ruby gem that basically just watches a folder, and then you have a little piece of code that says, if something here has changed, run this command. So it's just a watch file, and that works in any language. And the Guard files are really easy to configure. Yeah.
What about code coverage?
That's a fantastic question. One of the big things right now is code coverage. You know, and there are people that debate whether or not code coverage is a good metric or not. I think it does tell you something useful. There is a great tool out there for Node called Node Cover, and it's pretty good, pretty awesome. There are a couple other ones out there. JS Cover is an older code coverage tool that creates intermediary files. The advantage of using Node Cover is it doesn't create intermediary files to actually do the coverage, which is kind of nice. There's also a Sonar plugin that I have tried desperately to get working, but not so much. As far as on the Java stack, one of my goals in the next few months is taking Node Cover and converting it over to something that runs on Rhino, so I can get it running in the JVM and in Maven, and then in my CI server.
Is there a way to test elements?
So that's a good question. So like you're talking about if you add event listeners and such, right?
And you can test if the add event listener method is.
Exactly right. I mean that's one of those things where, yeah, I think it's possible. But what this does is it's just running on a fake DOM right now. Like my tests run on EnvJS, so it's going to load up a DOM for you, or if you're running in a browser, also load up a DOM. I believe that although I've never tried it, it should be pretty straightforward to bind an event or trigger an event and add that listener, and then catch the callback that's going to come from the listener and make sure it was called.
Tell EnvJS that, hey, I'm mousing over this thing.
Exactly right. Because they're just events, you can trigger whatever you want, right? So since you can trigger manually in the DOM, it shouldn't be that much of an issue to do that in some unit test code. Yeah.
As a follow-up to that, I wrote a UI widget, it's a jQuery plugin, and I tested that when something was clicked, it manipulates the DOM a certain way. Absolutely.
Cool. That's awesome. Are there any other questions right now? Yeah, go for it.
Jenkins, I was wondering if you could show how you can.
Wow, you're like Segway man. All right, great. That is exactly what I wanted to do next. Amazing. All right, great. It's great. All right, so that is exactly what I wanted to do next. I'm giddy with excitement that someone did that. You rock. Let me set that up. I just want to take the tests that I have right now, dump them in here, and make sure that they run, and then I'm going to do it in Jenkins. So give me a second. These are I feel like you see a cooking show, and you're like, oh, I'm going to make some stuff, and then they pull out the turkey, like, and it's done, and you're like, you bastard, So that's what I'm going to do right now. So bear with me for a second. I'll just steal this stuff, copy, and use my high-tech Macintosh computer. Sauce main web. Oh yeah, replace it. All right, and now my high-quality tests that hopefully work. You can do this at home by just stealing other people's code and copy it and pasting it. It's well, they do say that the best programmers steal. That's the way to do it. Only a fool writes their own stuff. Place it. Okay, great. So let's make sure that my copy and paste job actually worked by running all the tests. What? Awesome. And I'm not Trevor. I'm not Trevor. Right. What's that? What? All right. So there you go. You see my tests are working. That's great. First of all, let me show you that this works in Maven. And I'm going to show you the file, which is really ugly, in Maven for this. Maven's a mess. If you've ever used Maven, I'm sorry. It's too bad for you. But for us that live in that hell, it's not hell. Everyone loves Maven. Come on. It's the best. So let's take a look at this pom.xml file. That's pretty easy to read. So make it smaller? Yeah. I'm not going to make this bigger because I don't care. All it matters is that you're going to go on GitHub and you're going to copy all this shit. Oops, I mean stuff, and put it in your pom.xml. All right. So see this big thing from here to here? Just like cut, paste, you're done. All right. That's Maven for you, right? And if you super duper mega care, then there are things you can tweak in here, but I'm not going to go into them. That's dangerous. But basically, this crap is stuff that you'll put into your pom.xml, and once you have that there, then you can run Maven test, MVN test, and it'll do a bunch of stuff, and it'll test your Java stuff, and then it'll run Rhino, run all your tests. One of the cool things that we did here is that if you run on the command line, there's green and red, but we found out that if you have green and red in Maven and you put it on your Jenkins server, you get this ugly codes everywhere. So that sucks. So we just tweaked it so each one of these things run by themselves. One of the other nice things that we did is we actually have each of the test spec files run independent of the other test spec files. One of the big problems we had in the very beginning of writing EnvJasmine was that you would include all of these files and you include them all globally. So if I had some code in one of my files that messed with the global namespace, I almost cursed again, messed with the global namespace, and then later on I have another file that I loaded in my test suite, it screws stuff up. Another thing that we fixed was early on, the sort order really mattered a lot, but by making each of the specs run independently, it took care of the sort order issue. So there's a bit of thought that went through in that. Okay, so that's great. You've seen it run in Maven. So that's how it's actually going to run in Jenkins. So let's load up Jenkins. Ta-da! So Jenkins is cool. This is me just loading it up on port 8080 on my local machine. Jenkins is just a WAR file. If you're not using any continuous integration, I strongly suggest you check out Jenkins. It was called Hudson before. I'm sure there was a lawsuit or something and they had to change their name. But Jenkins is up and running, and then you just go to localhost 8080. This is how you can kickstart doing some continuous integration here. So let's go here, and we'll go to localhost 8080. Oh, nice. Wait for it. All right, great. So I actually have something already set up, but that's sort of cheating. So let's set it up. I'll show you how pretty straightforward it is to set one of these guys up. So I'm going to create a job, my jobs, and I'm going to call it a Maven 2 or 3 project. Bloop. Okay. And then once you're down here, this is how you set up stuff in Jenkins if you've never done it before. All the things the only thing you need to do is change this pom.xml file to where your pom.xml file is on your operating system. So here it is on my operating system. I'm going to go over here, and this is a little trick I always use, because if I just copy that onto my web browser, it would go to the pom.xml like it's a web page, because web browsers are stupid. So you copy it into terminal, because terminal is smart. Thank you, terminal. All right, plop that in. Bloop. Great. Hit save. So that's it. That's all I need to do. And now I build by clicking build now. And I'm going to click here, take a look at the console output, and you can see all my stuff is running just like you saw it on the command line. So there it ran and it passed. So let me show you what happens when it fails. So that passed. That was awesome. Now I have my JavaScript stuff in Jenkins. That means I can break the build. So that's great news. So let's write some bad code. That's easy. I write bad code all the time. Let's see, refresh. So I'm going to we'll do the easy one, right? Oh my God, that's ridiculous. Look at this. So I'm going to say hello and change this to goodbye. As we saw earlier, this is obviously not going to work, right? So if I rerun my tests in my jobs, you're going to see it break. Build it. Let me go to the console output, and we're going to see our things run. So I just want to show you how straightforward it was to actually run these things. So boom, this failed, and I got a build error. I got a build error. It's amazing. It's great. Like, JavaScript people weren't able to do build errors before, but now you are. Congratulations. Now I've finally achieved the goal that I can tell you how dumb you are. And it feels good. It feels so good. That when I realized how dumb I was, it made me very happy. And this is why I go to work. It's just very satisfying to know this. So that's how you set it up with Jenkins. Pretty straightforward, I think. If you have any other in-depth Jenkins questions, you can let me know. I think we're almost done. So let me switch back to my slides. Whoop. So that's where this presentation is. You can go check it out. So I'm using Impress.js here, which is kind of cool. Yeah, right? So you can check that out. Impress.js is really easy to use, except there are no tests for it, so that kind of sucks. Maybe I can fix that for him. Anyway, so that's my presentation. That's where I stand in JavaScript testing. I hope if you're not doing JavaScript testing right now, that you can go try it out. Go check out EnvJasmine. Go check out PhantomJS. Like just write some simple tests and see it work. And like I said, get it up and running in Jenkins and be a rock star. Be the guy that makes the build break. That's my goal for you. Thank you.